Hello everyone. Welcome to my channel Regular Learning Academy. I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about observable canonical form or second companion form, problem number 11. Lecture series on state space analysis, lecture number 24. This is state space analysis and control system subsets. So our new problem number 11, by using observable canonical form or second companion form. So what is the problem? This is the problem 11. Consider the following transfer function ys by u of s equals to s plus 3 divided by s cube plus 9s square plus 24s plus 20. Obtain the state space representation by using observable canonical form or second companion form. Calculate state space equation, state matrix, state diagram, and stability of the systems. So our given transfer function ys by us equals to s plus 3 divided by s cube plus 9s square plus 24s plus 20. And this is the ys output, overall output, and u of s equals to system input. And this input may be step, ramp, parabolic, and any type of input you can apply. And what is our target? By observable canonical form or second companion form, from this transfer function to calculate state equation, state matrix, state diagram, and stability of the system. So starts solution. Step number 1, the given transfer function is as ys by us equals to s plus 3 by s cube plus 9s square plus 24s plus 20, where numerator terms is called zeros and denominator terms is called poles. Step number 2, cross multiplication, and we get just cross multiplication. That means ys into this term and us into this. So what is the cross multiplication form? First s cube into 9, s cube into ys. So s cube into ys. This is s cube into ys. Then 9s square into y of s. 9s square into y of s. 9s square into y of s. 24s into y of s. 24s into y of s. This is 24s into y of s. 20 into y of s. 20 into y of s. And us into s. us into s. s into s. This is the us into s. And us into 3. us into 3. This is the 3 into us. So cross multiplication complete. Then s cube, this is s cube into ys plus 9 into s square into ys plus 20 s into s. In this position s, and also in this position s. So s common, 24 into ys minus u of s. Again 20 into us, this is 20 into us minus 3 into us. Minus 3 into us. Then divided by maximum power, and we get here the maximum power is s cube. So divided by s cube terms, and we get ys plus 9 into s square by s cube, 9 into s square by s cube, just divided by s cube, just divided by s cube. This term by s cube, this is by s cube, s by s cube, 1 by s cube, just divided by s cube terms, highest power s cube terms. Then ys plus 1 by s, 9 into ys plus 1 by s square, 24 into ys minus us plus 1 by s cube, 20 into ys minus 3 into us equals to 0. And again, ys equals to what? Just left hand side ys and other terms right hand side. Then we get minus 1 by s into 9 into us plus 1 by s into 1 by s square. This is us minus 24 into ys plus 1 by s cube into 3 into us minus 20 into ys. This is the, here put ys equals to x3s. Total term equals to x3s. x3s. So first condition, put ys equals to x3s. First term ys equals to x3s. Then x3s equals to what? x3s equals to 1 by s common, 1 by s common. In this position also 1 by s common. In this position also 1 by s common. So 1 by s common. Then this is minus 9 into ys. So write down minus 9 into ys. And next term equals to x2s. This is equivalent to x2s. x2s. Again x2s equals to what? x2s equals to just 1 by s in this position. Second time 1 by s common. So this is 1 by s us minus 24s plus this is equivalent to x1s. This is equivalent to x1s. So this is the x1s. Then x1s equals to, just write down 1 by s, 3 into us minus 20 into ys, minus 20 into ys. What is the process? This slide or procedure calculation. First ys equals to minus 1 by s to the power 1, 9 into ys, 1 by s square, us minus 24 ys plus 1 by s cube, 3 into us minus 20 into ys. Then y of s equals to what? 1 by s to the power 1, 1 by s to the power 1 common. Then when 1 by s to the power 1 common or 1 by s common, then just minus 9 into ys, and in this position 1 by s common, so 1 by s into us minus 24 into ys, and in this position 1 by s common, so 1 by s square into 3 into us minus 20 into ys, minus 20 into ys. Then 1 by ys equals to what? Ys equals to 1 by s common minus 9s constant plus total this terms equals to x2s. This is the x2s. This is the x2s. So write down ys equals to 1 by s minus 9 into ys plus x2s. This is equivalent to x3s. So x3s equals to what? 1 by s minus 9 into ys plus x2s. And x2s equals to what? x2s equals to 1 by s common. This is also 1 by s common. So 1 by s us minus 24 ys into 1 by s into 3 us minus 20 into us. So this is equivalent to x2s. x2s equals to 1 by s1. This is the 1 by s1. us minus 24 ys, and this is equivalent to us. So this is the ys equals to x3, and x3s equals to 1 by s equals to this, and x2s equals to this. So this is the x1s equals to 1 by last term, x1s equals to 1 by s into 3 into us minus 20 into ys. So x1s equals to this term. This is the very important. This is the x1, this is x2, and this is x3, and output ys equals to x3s. Output ys equals to x3s. So Step number 3, multiplying both sides by s, and we get ys equals to x3 output, and this x1 x x2s x3s. When multiplying both sides by s, then we get just multiply 1 by s. So s into x3s, this is s into x3s, s into x2s, and s into x1s, and s into x1s. So s into x3s, s into x2s, and s into x1s. And then taking inverse Laplace transform, we get this is the x3 dot, this is x2 dot, and this is x1 dot. This is x1 dot. So next step, taking inverse Laplace transform, and we get this is s into x3, s into x2, s into x1, and we get x3 dot equals to what? Minus 9 into y of t plus x2t. And this is x2 dot, this is x2 dot because first order differentiation equals to u of t minus 24 into y of t. This is 24 into y of t plus x1t, and last term x1 dot equals to 3 into u of t minus 20 into y of t. So these three equations are very important. These three equations, x1 dot, this is x1 dot, this is x2 dot, this is x3 dot, x1 dot, x2 dot, x3 dot, actually state equations of the system, given system, state equation of the given system. So what is the x1 dot? x1 dot, x2 dot, and x3 dot. This is x1 dot, x2 dot, x3 dot, and put yt equals to x3. Then we get x1 dot equals to what? 3 into ut minus 20 into x3. Again, x2 dot equals to what? x2 dot equals to u of t minus 24 into x3, yt equals to x3. So put here this corresponding x3, put here x3, and this is x1. Similarly, x3 dot equals to what? x3 dot equals to minus 9 into, this is equivalent to x3. This is y of t equals to x3, and this is x2. So x1 dot, x2 dot, and x3 dot, state equation calculation complete. Then the equation, state equations are x1 dot, x2 dot, x3 dot. These are all state equation. 0 x1, 0 into x2 minus 20 into x3 plus 3 into u of t, 1 into x1 plus 0 into x2 minus 24 into x3 plus 1 into ut. x3 dot equals to 0 into x1 plus 1 into x2 minus 9 into x3 plus 0 into u of t. This state, and the state matrix is, this is the x1 dot, x2 dot, and x3 dot. This is left hand side, x1 dot, x2 dot, x3 dot, and the coefficient 0, 0, minus 20, and this coefficient 1, this is the 0, and this is the 24 minus, and this coefficient 0, this is the 1, and this is the minus 9, and this is the x1, x2, x3 coefficient, sorry, state variable. And what is the ut coefficient? 3, first coefficient 3, second coefficient 1, and third coefficient 0. Third coefficient 0. This is the state matrix, and this is equivalent to, x dot equals to x, this is ax plus b into u. This is equivalent to x dot equals to x plus bu, where x dot equals to this matrix, a equals to this matrix, and x equals to this matrix, b equals to this matrix, and u equals to u of t. So x dot equals to x plus bu. For what condition this system stable? When rank of this system n equals to 3, n cross n matrix, that means 3 cross 3 matrix. If rank equals to 3, then system is controllable, otherwise uncontrollable systems. The output equation is yt equals to what? Yt equals to only x3. So 0, 0, 1, x1, x2, x3 multiplying by x3 into 1. So yt equals to output x3 and state diagram. What is the state diagram? From equation 1, 2, 3 and output equation. This is the state diagram. This is the state diagram. So first, this is u of t. This is u of t. This is u of t, input u of t. This is the reference input u of t. And this is x1 dot. This is x1 dot. X1 dot equals to what? First follow. X1 dot equals to what? X1 dot equals to minus 20 x3 minus 20 into x3. So x3 dot x1 dot equals to minus 20. This is the minus 20 path and this is the x3 path. So minus 20 into x3. Minus 20 into x3. This is equivalent to minus 20 into x3 plus 3 into u of t. So this is the path 3 into u of t. 3 into u of t. So first state equation complete. X1 dot equals to minus 20 x3 plus 3 into u of t. Then x2 dot integrate. This is the x2. x2 dot integrate. This is x2. So x2 dot equals to what? x2 dot equals to 1 into x1. So this is the x1, this path x1. So 1 into x1 complete. And minus 24 into x3, minus 24. This is the x3 path. This is 24 path. This is minus. So x2 dot equals to minus 24 into x3 plus x1 and plus 1 into u of t. This is the ut. This is 1. So this is this path x1 minus 24 into x3 plus u of t. This is the x2 dot. And what is the x3 dot? x3 dot equals to x3 dot integrate. This is x3. When x3 dot integrate, this is the x3. x3 equals to output ultimate y of t. x3 dot equals to output ultimate y of t. And x3 dot equals to minus 9, 1 into x2. 1 into x2. So this is equivalent to x2. This path x2 because x3 dot equals to x2 and plus and minus 9 into x3 minus 9 into x3. This is x3 path and this is minus 9 path. So 9 into x3 plus x2 and 0 into u of t. So not connected in this position. Not connected. Then this is the signal flow graph. This is the signal flow graph. This is the signal flow graph. First u of t. This is the u of t and this is 3. This path 3 and this is x1 dot. This is x1 dot. x1 dot. x1 dot integrate. This is x1. This is x1. x1 dot integrate x1 and x1 dot equals to what? x1 dot equals to minus yt equals to x3. yt equals to x3 minus 20 into x3 plus 3 into u of t. So first equation satisfied. Similarly, this is the minus 24 path. This path minus 24 into x3 and this is the minus 9 into x3. This is the minus 9 into x3. So this is x1 dot. This is x2 dot. This is x2 dot. x2 dot integrate x2 and this is x3 dot. x3 dot integrate x3. This is the x3 path and this path 1. So this is the 1 path. This is the 1 path. This is the signal flow graph for this block diagram. And in this situation, what is the matrix from? This is the matrix for special type of matrix. This is the special type of matrix because only one column or last column, minus 20, minus 24, minus 99, minus 9, and this diagonal elements 1. So this type of matrix is called second companion form or observable canonical form. This is the observable canonical form matrix. This is the observable canonical form matrix. This is already discussed. Thank you.